Hello everyone. Today we are going to create an algorithm that we can apply to any solid body to create a waffle structure. After we create that waffle structure, we will be able to extract the curves that we will put into the laser cutter if we want to create that shape. What are we going to be able to change? Well, not only we will be able to change the geometry, we'll be able to change the thickness, we'll be able to change the distance in between panels in one direction or the other. And we will also be able to change the fitting scale that will help us create the perfect size of fittings according to our laser cutter or material. This distance right here, we'll be able to change it by changing the fitting scale. After all that is done, we will have automatically have our curves. That we will be able to optimize after we bake them to introduce them in our laser cutter. So I created this airplane on Rhino using the sub-D tools. Now I'm going to bring it to Grasshopper so we can start manipulating it. So I'm going to get a brep component and then right click, set one brep. Okay, and this one, actually what I'm going to do is internalize the data. So I'm not depending on the Rhino file to open this algorithm. So if I do that, I can get rid of or I can delete the file, the geometry in in Rhino, and I can open it, just the Grasshopper file. If I wanted to edit it, I would have to bake it again, and then bring it back on, then set one rep again. But this way I only have the files in Grasshopper, or the geometry in Grasshopper. Okay, so the first thing that we are going to do to create the waffle structure, there are different ways to do it. The one I'm going to use, and then I'm going to explain you another one, it's going to be with the contour lines. Okay, so I'm going to go get the contour lines. Okay, and then this asks for a shape, a starting point, which is defined as the 0, and then the direction of these contour lines. So the first ones that I'm going to create, I'm going to go on my X axis. So I'm going to put that on the direction, and then the distance in between them, I'm going to create a slider from 1 to 50, for instance, and then I'm going to put it on the distance. So if we put a shorter distance, then we will have more subdivisions. If we have a bigger distance, then we have less subdivisions. So I'm going to put it maybe 10 or 20. And if I turn this off, you can see that we already have those lines. Okay, so we need to make the lines in the other directions so we can create the fixings. Okay, how they fix with each other. So I'm going to copy this, actually just the contour and the slider, and then I need to set up the other direction of the contour lines, which is going to be, in this case, the y-axis. Okay, and then we have the other group of curves. Okay, we can define the distance independently. of each of them. Okay, I'm gonna put maybe 25, so we don't have that many curves, as it will make our file bigger. But yeah, that should be all right. We can change it at any point. Okay, so the next thing that we can do is create surfaces. So I'm gonna go get the boundary surface. Sorry. And I'm gonna connect this, and I'm gonna do the same thing with the other direction. Okay, now that this is done, I can extrude those surfaces in order to create a boolean difference between each of those directions, and then create the fixings. Okay, so I'm going to extrude, and these ones are going to go on the x direction. So, but I need to define the distance. So the distance of the extrusion is going to depend on the thickness of the material that I'm planning to use if I want to laser cut it. Okay, so I'm going to get an amplitude component, okay, which help us create a vector, and then the direction of that vector, we want to extrude these ones here. I want to extrude them in the x direction. So I'm going to connect this here, and let's assume that I have a thickness of a board of 2.5 millimeters. I'm going to create a panel because I'm not going to change that. Okay, so if you are very detailed, or you will see that this is being extruded in one direction from the curves, but I want the curves to be in the middle. I mean, I wanted to extrude it half to one side and the other half to the other. So what I'm gonna do is just divide this number by -2. Sorry, actually what I'm gonna do is move it. Yeah, divide this number by -2, and then I'm going to move this geometry in this direction by -2, and that way it's going to be centered in the the curves it's going to be aligned with the curves. Okay, and I'm going to do exactly the same right here. So I'm just going to copy this, and the only difference right here is that my vector is going to be y direction, the y axis. Okay, and it's already centered. So another way to do it, to make these solid bodies that are the ones that we need to create the boolean difference, would be as follows. So I will just show you this second method, and you can choose. It will just have different parameters, and yeah, you can just depending on what you need, you can choose whichever you want. So I'm going to create a bounding box, and then out of that box I'm going to deconstruct it. Okay, and then I'm going to grab, I'm going to turn this off. And turn this off, and I'm going to get two edges with the list item, and this is going to be one of them. Okay, and what I'm going to do with this, I'm going to get the other one after, but what I'm going to do with it is I'm going to create perpendicular frames. Okay, and once I have those frames, I can control the amount of them that I want. And in this case, those frames would be defining the surfaces that I would be extruding. I wouldn't be controlling the distance in between them, but I would be controlling the quantity. How would I do that? Well, there is a component in the intersection. So it will be this one right here, the brep plane component that I need. So the brep is this one. And the planes are this one. The planes are this one. So if I turn this off, I would have those curves. And then I would just follow the same procedure. I would just go right here and extrude, etc., etc., etc. You can see right here that as we have one plane at the end, I mean at both ends of that curve, and that curve is exactly the same length as the plane on, because we did it out of a bounding box. What we will have to do is either scale that curve and make it slightly shorter, or the other thing that we could do is maybe clean that 3. Okay, this is going to be the 3, and we would want to remove the empty components. So I'm going to invert this, and then our tree is not going to have any null or empty branches, so it's going to be fine. Okay, then we will create the surfaces and extrude them, and all of that would be the same. To create the vectors for the extrusion direction, for the extrusion, we can use the frames. As if I use a frame as a vector, it will just create a vector, a normal vector, or a perpendicular vector to that frame. So that would be a different way to do it. In this case, we will be controlling the amount of divisions. In the first case, we'll be just controlling the distance in between the divisions. You can choose any way you want, or any way you need. Okay, so coming back to the first method. So the next thing that we want to do is make Boolean differences to create the fixings in between both directions. So what we're going to do is try to find the intersection of each direction, and then make a bounding box. So I'm going to find the brep component, this one right here, and let's see what happens if we connect it there. So if I select it, you will see that it's it's only showing me an amount of intersections there. So what I'm going to do is I'm going to use the cross-reference component. Okay, and I'm going to make this a list. I'm going to flatten this and flatten this as well. And then I'm going to connect it here and here, and then I'm going to connect them there. And now we have all of them. Okay, so that being done, I need to create bounding box out of those curves. I'm going to turn this off for a second. And then I'm going to get the bounding boxes. And if I connect those curves here, okay, I'll get some of the boxes. It is creating extra boxes because those lines are not, I mean, they're not closed. Those curves are not closed. So what I'm going to do is right click on the bounding box component and make a union box. Okay, and then I have those boxes. If I turn this off, okay, you will see that there are those boxes. If you have a look at the output of it, it seems okay. Okay, now that we have those boxes, what I want to do with them is that Boolean difference that we've been mentioning. So the Boolean difference, I want to, for instance, if I turn this on, I want to extract material out of this shape with half of those boxes, because with the other half I'm going to extract the material of the other geometry in the other direction. So to do that, I'm going to move those boxes. Okay, I'm going to come here and move, and I want to move them in the Z direction. But how much do I want to move them? The distance that I want to move them is pretty much the length of those boxes. But what I'm going to do to get the distance of, or the how much those each of those boxes are, I'm going to create another brep component. But this time I'm going to be connecting these surfaces. Actually, I'm going to get another cross-reference, and I'm going to flatten the input, both inputs. Sorry, not graphed. And if I do this, I would have all of those lines. Okay, and now that I have those lines, I can measure the length of each of them. So if I go and get the length component, okay, I have the length of each of those lines. And if I divide that number by 2, okay, then I'm moving those boxes the right amount. Okay, so once we've done that, we are going to create that Boolean difference to create the fixings. So the Boolean difference is going to be with the boxes. Okay, I'm going to flatten this with the geometry in one direction. So if we do that, I'm going to turn this off, and I'm going to turn this off as well, and this one as well. And there we have it. Okay, so once we've done that, we can do exactly the same thing with the other direction. So the only thing that is going to change is going to be the direction of this vector right here. So I'm going to get another move of these boxes, and then I'm going to get a negative, and this is going to be the moving direction. And now my Boolean difference is going to be here. And this time is going to be with these ones right here. So if I turn this off, okay, I have, yeah, those fixings already done. So it could happen that if we are making those boxes out of the exact same thickness of the material. So depending on our laser cutter and many other factors, it could happen that those fixings are either too tight or too loose. So if we wanted to control that, which is the reason why we are doing all of this, what we have to do, or what we could do, is actually scale these boxes. And depending on that scale, we're going to remove more material or less material depending on what we want. So what we want is scale. In this case, we're going to do a non-uniform scale because we wouldn't want to scale on the z-axis, only in the x and y axis. The geometry that we want to scale is this one, the boxes. And yeah, let's put a slider from, let's say, 0.50, which is a lot, but let's put it anyway, until 1.50, which is also a lot. But yeah, so we can see what can be done. And I'm going to connect this right here, and the plane is going to be on the center of each of those boxes, which I'm going to get it from the volume component. There we go. So if we turn this off, we can see that we can change that thickness, or the size of that boxes, those boxes that we are using to remove material. So I'm gonna put this somewhere here. And this will be connected to this geometry and to this one right here. I'm gonna turn this off, and I'm gonna turn this back on. Okay, now it's a number above 1, so we are making them bigger, and we can see that those fixings are a bit loose. Okay, so depending on, as I said, the laser cutter that we're using, the power and all of that, we might have to adjust this however we want. We might want it to be very tight. We might want it to be a bit loose. Okay. Okay, so I'm gonna, as we are already having a rather big or long algorithm, I'm going to organize it a little bit. So for instance, of this, I'm going to group it. This is the beginning. And then we start making those fixings. And here we have our 3D parts. Okay, now that that's done, the other thing that we said that we would do is from the 3D parts, we need to take out the curves that we are going to be using to put in our laser cutter. Okay, so I'm going to turn one of these off, and I'm going to work with only one of them, and then we can copy the algorithm, as it's going to be very similar to the other one. So to extract the curves of each of these solids, what we're going to do is find the biggest face of each one of them, and then extract the edges of it. So we're going to use the brep edges component, and then we are going to use the deconstruct brep. So we are going to connect this here. I'm going to turn this off. And what we want from the deconstruction is the faces, but we want the bigger face. So we are going to measure the area of each one of them, each of those faces, and then we are going to sort that list of faces. So we are going to flatten this. No, we're going to leave it as it is. We're going to connect it here and here. And if we have a look, if I get a panel, and this would be the opposite. I didn't connect them right. Okay, so on the output of the values, I'll have the faces, and on the output of the keys, I'll have those areas that are already sorted from smaller to big to larger one. So in each of those trees, those areas are sorted. So what we have to do is reverse those lists, and then we have to extract the first one of each list. Okay, so for instance, on the first branch of that tree, we have this is going to be the biggest face, the largest face or surface, and I'm going to reverse this, and I'm going to get a list item. Turn this off, and you can see that there are the faces. Okay, next thing that I'm going to do is extract the curves of those faces. These are going to be the naked curves. I'm going to join them as they are polyline. I mean, they are not connected with each other. If I turn this off now, we will see those curves. Okay. The next thing that we have to do is spread them. Okay, on our X and Y axis on our plane, so we can send them to the laser cutter. So to do that, we need the orient component, which we are going to orient this geometry. So as for the source input, we would have to create planes where those curves are. To do that, we can do it in many different ways. What I'm going to do is use this plane fit component. That what it does, it just creates a plane out of a group of points. So if I take those surfaces, or the main surfaces where we extracted those curves, and I deconstruct them, if I deconstruct those breps, I can extract each vertices or the group of vertices of each of those faces. If I connect it here and I turn this off, then I will have different planes on each of those curves. So if I take that and put it on the source, okay, I'll turn this off and I'll turn this off. I have the curves for the laser cutter. They are not properly oriented, and neither they are optimized on the surface that I'm going to cut, but I can do that manually. What I can do now is move them along the x-axis, for instance. And I'm going to use a series. And the other thing that I'm going to change is I'm going to find a list length. This length right here. And I'm going to take, for instance, this one. I'm going to flatten this. This is going to be the amount of elements on the list, and I'm going to flatten this as well. And then I'm going to create a slider to control this step, which is going to be, I don't know, from 10 to 100 maybe. And this one I'm going to turn this off. And there I have the curves. Yes, as I said before, we'll have to reorganize them. But as there are not that many curves, we can just optimize them or spread them in the software that we're going to use before sending it to the laser cutter, or we can do it here. It's not going to be a big deal. So in order to create the other group of lines, I'm going to create the planes in a different way. So I'm going to copy all of this. And paste it right here. And now our reps are going to be these ones. And you will see it spreads it right there. It's okay. But I'm just going to show you a different way to create those planes that we're going to use on the source. Okay. So we have different ways to create planes right here on the vector section. Here we have, just different ways to create planes. And I'm going to use this one right here. It's right here, construct plane. And what it asks us is an origin that I'm going to be using, or maybe what I'll do is just get the area of each of those faces. And the centroid is going to be the origin of each plane. And then my y-axis of each of those planes can be my z-axis from the universal plane. So there I have them. Okay, and I could move them upwards on the y-axis so I can see them. Okay. Yes, I'm going to turn this off. And then I can spread them however I want. Okay. Remember, I can always go back to the beginning and change the distance in between those structures. We can change the thickness, and very importantly, I can change the size of those fittings. Okay, which is the whole point of this. And then I can bake the curves and spread them however I want. Okay, I hope you enjoyed this tutorial, and looking forward to see you next time.